All right, hi kids. I'm sorry I'm not here today. My daughter's sick, so what I want you to do is I want you to try to follow along with this. The sub should have given you um, a calculator, uh, kind of, I guess, not cheat sheet, but kind of how you work through your calculator so you can look through it tonight on your homework and then possibly as you look back at this lesson. But right now I'm going to kind of not really refer to the calculator cheat sheet, but you're going to want to look at that as you look at the rest of the problem. So we're going to start on warm up on page 135. So you need your textbook and your graphing calculator out and a pencil. So let's get started, all right? So it says Kira's training for a half marathon, which is approximately 13.1 miles. She recorded the distances and times of her recent runs. So we got distances here and time in minutes. So what we were doing is we are going to basically be putting this into our calculator and looking at it as a table. So we're going to call these our L1 units and these are L2. So we're going to put it in for L1 and L2. So the first column's L1, second column's L2. Now traditionally you make L1X and L2Y, but we'll talk about that in a second. So what it says is on here, create a scatter plot. But we're going to sketch what we see in our calculator. So we're going to take our calculator out. What we have to remember is how to reset our calculator. Mine's already reset, but just in case you don't remember, you hit the second button, then you hit the plus sign, and then 7, 1, 2. So that clears everything out. Now, before we get started, remember that this is a video, so you can pause, rewind, and replay it as many times as you want. All right, so now what we're going to do is we're going to type this data into our table. So I've listed here the steps that you're going to do. So you're going to hit first, second, then we're going to hit stat plot, and you're going to turn on your stat plot. All right, so you're going to turn it on. It should be off, but you're going to turn it on. Then go second mode, and now our stat plot's ready to go. So what we're going to want to do is now fill in our data so we can see our stat plot. All right, so we're going to go stat, and then we're going to go to edit, and that means we can type in our values. All right, so we're going to type in all our L1s here and type in all our L2s here. All right, so I'm going to type in my L1s. Oops. 7.8, 10, 7, 13, 5, and 8.5. All right, so once you've gotten in your L1s, you go over to the L2 column, and you're going to put in your L2s also. Make sure, speed is important, but also putting in the correct numbers, because as you see, if you do not type in the right numbers, you're going to get a really funky graph that's going to give you some bad data. So you want to go with some speed, but you want to also make sure that you're typing in the correct number. So sometimes I say the number out loud, and that helps me make sure that I type it in. Also, when I'm typing these things in, I'm using my thumbs like I'm texting, and that helps you do this a lot better and faster. So one little thing, you've done it right. If your L1 and L2 columns end with the same numbers, like they're at the same row, then at least we know that we've typed in the same amount. So now that we've done this, usually I type in my data and then I go second, y equals, and then turn my stat plot on. So like clearly my plot's already on because we've already done that. So I usually do that after I've typed in my data. And then what we do is we go to see our stat plot. We go zoom, and then we hit 9. And zoom 9 fits it. So there's our data. Wow, look at that. That looks awesome. So the whole point about today is we're going to analyze and fit functions. We're going to say what line of best fit fits our functions best. Since we've worked with all these different functions like linear, exponential, and quadratic, we can identify and say, hey, that data would best be served by linear or exponential or quadratic. So that's what we're doing today. So if you look at this, all right, what we'll do is we'll just take our little made up stat plot that I have here. All right. Ooh, why isn't this staying on top? Stay on top. Where are you, buddy? There you go. Okay. So now what we're going to do is we're just going to plot out what this thing looks like. So there, 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 there. Now, looking at this, all right, what this next problem number 2 says is care estimates her time to can be approximated using this function. Draw the line of this function on the scatter plot. Well, here's the deal. Since this is a mock graph, we're going to put this into our calculator. So we're going to go y equals, and we're going to type this function in. So we're going to go 10.5 x x, and then minus, well, I think that's the negative button. I gotta just type it in here. Minus 20. All right. Now, in the same Zoom 9 button, Zoom 9, I'm gonna see my scatter plot. Now look at that. Now, you guys have actually had tons of practice working with lines of best fit in Math 1. So if you look at that, is that a good fit for her data? And we would say yes, because it kind of goes above and below all the lines. It fits your data. It goes, let me use my pen. Come on, there we go. It goes through all the points. And that's a reason why it's a good line of best fit. It goes through. If it was just above it or just below it and not really touching it, it really wouldn't be a really good piece of data. So now, what this line of best fit is it's a good approximation for how long it would take her to finish a half marathon, or going how far in miles, how long she would have been running for. So now it says, based on the function y equals this, what's Kara's predicted time to finish the 13.1 half mile marathon? Well, this 13.1, all right, oh, sorry, this is your miles, and that's your x value. So we're going to put 13.1 in here, and we're going to calculate. So we're going to go 10 times 13.1, all right, and you're just going to calculate that in your calculator. So for me, I'm just going to look at this, all right, I'm going to look at this, second quit, I'm going to go 10.5 times 13.1 minus 20, and you get approximately 117.55 minutes. So we'd say about 117.55 minutes. Ooh, and that's what we're doing today. We're using our line of best fit to figure that stuff out. So, all right, let's take a look at a problem that we're going to be looking at. So here is our idea of what we're doing. So not only are we using linear to model our data, what we can do is we can identify whether or not it's quadratic, best modeled by quadratic, or exponential. So this is our first problem. It's just kind of looking at a flu outbreak. So we have days since the outbreaks occurred, and then how many cases we have here. So now I don't want you to do this. What I've done is I've already put it up here on the screen here. You can see my data. So I have all the points and I've put these in. So if you look at it, it's kind of like a hodgepodge, not sure if it's best fit by linear or best fit by quadratic. And what I mean by that is down here it says create a scatter plot showing the number of cases. Well, we're not going to do this. I've already done it for you. All right. So it says a group studying the outbreak believes this function, all right, which is linear, is a good fit for the data, whereas another group believes that this function, the quadratic, is a best fit, and then a third group believes that exponential is a best fit. Which function is the best fit of data? All right, so what we're going to do is we're going to look and we're going to say, holy cow, if we put all three of these on here, some of these look good for linear, some of these look good for quadratic, and some of these look good for exponential. So what's going to be best? What's going to best fit our values? So, all right, here's the deal. How do we determine what is best? I don't know what's best, all right, because some of them look good for exponential, some look good for linear, and some look good for exponential. Well, I'm going to tell you how we determine what would be best, and that is using a residual plot. Now, these are going to be notes that I want you to take on page 136, all right? On page 136, all right, this is residual plot, and you have seen this before. So residual plot is a way that you actually look at your data that you've typed into your calculator in comparison to the line of best fit. And what you're going to do is you are going to look at this data and you're going to say, all right, based on the data that I was given and then a line of best fit that I've either calculated myself or was given, what I can do is see how closely related the data are to each other. So is it a good fit or a bad fit? So when looking at a residual plot, all right, your residual plot is not your scatter plot. It's a separate plot that you're going to access on your calculator. And these are the two different plots that you'll see. You'll see a random plot and then a pattern plot, or what we would consider a U-shaped. All right, U-shaped plot. All right, and U-shaped, all right, when you have a pattern or U-shaped, whether it's downwards or like it opens upwards or opens downward, as long as it's in U-shaped, it's not a good fit. It's bad. It's a bad set of data. And basically what it means, all right, in a nutshell, is your x-axis right here acts as your line of best fit. That's what it acts as. It acts as your line of best fit. And these are points that are below your line of best fit or above. These are points that are below, and these are points that are below, or above again. So if you look, your line of best fit is really only good for this point and this point. So U-shaped is not good because it only works for like a very few of your points, where it gives you some good relative data. Now random is a good fit. Random, that's what we want when we look at our line of best fit, because again, your x-axis is your line of best fit in a residual plot. All right. Whereas, yes, another 2 points, 1 and 2, is really good with it. But if you look, some, like, it keeps interchanging. Like 1 is below, then 1's above, then 1's on it, then 1's above again, then 1's below, another 1's below, 1's above, 1's on it, 1's below. So because it scatters up, down, up, down, up, down, up, down, up, down, up, down, up, that's a good fit. But if it doesn't scatter, if it's like 6 in a row or above, then 6 in a row or below, then another 6 or above, that means that your line of best fit kind of just shot through your points and only touched a couple and really didn't fit it well, whereas random is a good fit. So that is knowledge from last year, but that's what we're going to do to determine if your line of best fit is truly the best fit for your data. Okay, so here we go. We're going to do a couple examples, all right? And I'm going to kind of show you how to find your residual data, okay? So what we're going to do is we're going to take this example, and this is L1 and this is L2, and we're going to put this in our calculator. But here's the deal. Because we had already done a problem on here, we have to reset our calculator. Second, plus 7, 1, 2. Now, because we reset it, that means we also have to access our scatter plot also, all right? So we're going to hit Stat, Edit, and we're going to type in our data. So we're going to type in our L1 stuff. Now, what I'm going to do, because it's kind of dead air, is press play once you've typed in all your data. All right, so now, once you've typed in your data, all right, you should end up, again, 5,414 should be at the bottom. All right, one thing that helps me out is I just count how many I have down. I have 10 pieces of data here and 10 here. So if I were to actually scroll up and look at what number, see how it says L210? That means 10 pieces of data are here, 10 are here. So at least I know my data is correct. So let's take a look at what the scatter plot looks like. So we're going to go second, y equals. Our plots are off clearly because we reset it. We're going to turn them on. And then once we turn it on, we hit enter and it's flashing on. We go zoom, 9, and bam, there's our scatter plot. So if you look at it, right now it gives us an idea of linear. So here's the deal. All right, what we're going to do is we're going to sketch this. We're just going to kind of do like a little mock sketch. Now this is a really accurate sketch. See how it's like scaled and labeled? You'll never do one this accurate, but the book does it. I'm not going to do it that scale. That I don't have time, and especially on my calculator or on my computer, I can't do it this nicely. All right, but if you'd like and you want to put them accurately on there, like this should go here and here, totally fine. But me, I just model what my calculator looks like. And there it is. All right. So now what we want to do is we want to say, all right, is this a good line of best fit? Now, here's the deal. Your calculator will not be able to determine if a random line of best fit is good. What your calculator will do is it will actually show you the best line of best fit. So I'm going to show you how to do that, all right, because that's how you actually do these problems. You don't actually use somebody else's. You're actually going to let your calculator find it, and then you're going to look at what your calculator gives you, and then what the book thinks is best, and you're going to determine if they're good or not. So, ready? Once we have this data, we are going to make our own line of best fit. We're going to go stat. we're going to go over to calc. So stat is how you type in your data, but if you scroll one over to calc and you go down to 1, 2, 3, linear regression, that means you're going to get your line of best fit. All right, that's what we want. LinReg means your line of best fit. Now, the reason we want to go to LinReg and not something else is because, to me, linear looks like the best data. If you thought it was exponential or quadratic, you would just go down here and you'd go down to QuadReg if you thought quadratic, like a U shape was best, or you go down to number 9, LNReg, 0, which is exponential regression. An exponential is you think it's exponentially. It would be best modeled by that. But since the book says it's linear, we're going to do LinReg. So we're going to go to number 4's LinReg, and we're going to hit enter. Now, all right, once you do this, old calculator and new calculator are going to have some different prompts. Old calculator, all right here, what I'm going to do is I'm just going to hit enter, all right, and it's going to shoot up my answer. Old school or new school calculator, you'll have like store, reg EQ, all that stuff. So what you just do is you just click down to calculate, and this is what we got. So if you look, the book or my calculator actually thinks that A, notice here, y equals ax plus b. My A is negative 0.0049, which is approximately 0.005. Holy cow. And then my B is 44.01, which is almost 44. So my calculator thinks that this is the best line of best fit. Our book thinks that it's the same thing as the best line of best fit. So it must be the best line of best fit. Hold on. Technically, you have to look at what your residual looks like to determine if it's good. So clearly our line of best fit is identical, all right? So we will use this if our residual plot is good. So I'm going to show you now how to see a residual plot. So go back to Zoom 9, all right? This is our scatter plot. Your residual plot is different. So how do we get our residual plot? Well, what you do is you go second, all right, stat plot, all right, and what we got to do after you calculate your line of best fit, you go to plot 1, go to the one that's on, and what we're going to do is we're going to go down to Y list. You see this Y list right here? And what we do is we go to vars, Y vars, function, and then, where is it? Come on. All right, I apologize. Hold on. So you go to your Y list, and you don't go vars, you go second. So once you're on L2, you go second, stat. So we're going to go a list. And because we did our line of best fit, we can now calculate our residual and see our residual graph. So you go down to number 7. And now we're calculating our residual from our data. So now what we do is we hit enter, and we go zoom, 9, and boom. There's our residual data based on our line of best fit. So if you look at it, our residual data is random. So as we flip the page, all right, as we flip the page, we are not going to calculate this. Good Lord, we're not going to do this. But we are going to plot and sketch our residual. So our residual down, down, up, high, down, 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 up, high. This is random. This is random. It's not U-shaped, so random. So what it says is determine if the line of best fit is a good model. And what we would say is yes, random, residual. All right? The random residual means that our line of best fit is good. So, all right, now it says determine the expected gas mileage for a car that weighs 2,700 pounds. So that means we got to go back and use our equation that we said was the best line of best fit. So y equals negative 0.005x plus 44. So y equals negative 0.005x plus 44. And pounds, if I believe from here, pounds were L1, which means x. So what we're going to do is we're going to put this, and we're going to put negative 0.005 times 2,700 plus 44. And what you're going to get when you substitute that in your calculator, you're going to get your answer. Let me make sure. Yep, we're good. So we're going to take our calculator, and we'll go second, quit, clear out of this, and we just go negative 0.005 parentheses 2,700 100 parenthesis, and now plus 44, hit enter. And so determine the expected gas mileage. It's going to be 30.5 miles per gallon. And there you go. So that's what you do. So again, you cannot determine if a line of best fit is good just by saying, oh, it looks like it goes through it. You have to look at the residual. This is what tells you if you can use your line of best fit, yes or no. Okay? So let's try another one. All right? Now, this is your residual cheat sheet. All right? So you see this. It literally walks you through how to create a scatter plot, how to create a line of best fit. All right? It then also tells you this. This is one thing that I didn't do, is storing your function. All right? Storing it means you can put it into your calculator, into the Y1 portion. I haven't done that yet, but we can. Now notice there's new calculator and old calculator stuff. All right? So you have to know, are you a new calculator person or an old calculator person? All right? They will do the same thing, but they have different little keystrokes here. And then lastly, how do you create your residual plot? So I've kind of done that without really looking at this. You want to make sure that you are going through these steps and looking at this, and that's how you practice this stuff. All right, so let's try another example here. All right, so it says in the mid-1980s, the U.S. Fish and Wildlife Service began reintroducing gray wolves into the region of western United States where the wolf population became endangered. The table that follows shows the approximate number of wolves in a certain region every 2 years since the reintroduction. So here we go. This is our L1. This is our L2. So pause and put this into your calculator, but make sure that you're going second plus 7, 1, 2, and clear, and reset your calculator. All right, here we go. So after you type these in, if you go back up again, we have 12. You should have counted. Oh, we have 12 things, 12 here. All right, we're good to go. So now let's see what our table is. Now it says here, it says 2 models have been proposed for this data, linear and exponential. Which model is best? So, right? So what we're going to do is we're going to go second, stat plot, and we're going to turn on our stat plot first. I want to see what it looks like. All right, so you turn it on, zoom 9. All right, now if you look at that data, I don't want to say it's almost slapping you in the face, but it is. That is exponential, all right? Now you can go ahead and you can say, hey, you know what? I'm going to try this linear. I'm going to see what the linear model looks like, but I'll tell you right now, this is your answer. This is your best fit right here. But let me show you what a bad residual looks like, all right? So say you look at this and you're like, yeah, that looks linear. Please don't ever say that, but say you saw it and maybe there's something that's you're not sure of later in the future. So if you were to have said, okay, I think linear is the best model, but I want to test it first. You got to go stat, calc, and you're going to say linear. I'm going to say, oh, linear is best. So I hit linear regression, boom, done. Now, we're not going to store it or anything. We're just seeing it. Now, this is the line of best fit that they give us. So they give us a slope of 49 and a y-intercept of negative 211. Now, if you look, that's different than what this book gives you. So that should be number 1, telling you that something's funky, just for this problem. In a normal problem, I wouldn't give you these possible examples. You would have to calculate it and determine it yourself. But okay, so you're like, yeah, this looks good. So that's not good enough. That's not good enough. We want to go zoom 9 and see what this really looks like. Now look at this line of best fit. Come on, buddy. Where are you? Oh, it's not showing up. Oh man, I forgot. So you will not really be able to get to see it unless you store it. So let's go back to stat, calc, linear. All right, so now because I have an old school one, I'm going to have to store it differently than how you would store it. So the way that you got to store it is you got to go, you go second 1, comma, second 2, comma. All right, and basically what you're saying is you're taking your L1 and L2 columns, and we're going to go vars, go over to yvars, hit function y1, and hit enter. And basically what that did is it gave you the same answer, but now it put it into your y1. I didn't do any of that. That's what my calculator did. So now when I go zoom 9, boom. If you look at that, that looks awful. That looks terrible. All right, so our line of best fit should be a parabola. It should be a parabola, but let's see what our line of best fit looks like as a residual. So clearly that looks like absolute garbage, but I want you to see what a garbage residual looks like. So we're going to go second, y equals, and we're going to change our scatter plot to be a residual plot. So we go to the one that's turned on, we go down to L2, and we're going to change that to residual. So you go second stat, and number 7 is your residual. All right, now if you're like, holy cow, he's flying with this. All these steps are on that little cheat sheet. I require and recommend you to look at those, all right? And then pause and redo this video if you need to. All right, so now that we got a residual, you're gonna go zoom 9. You gotta always zoom 9 it, and look at that. All right, now that line is our line of best fit. I didn't take it off, but this is a residual graph. That is an awful residual graph right there. Look at that, that's U-shaped. So clearly that's not linear. That's not linear. Now we should have known that right away, but do me a favor, and I want you to go second y equals, and we're going to go back to the scatter plot, and we're going to change it from residual to go second 2, and now it's back to how it normally looks. Go zoom 9. So now clearly that's our original graph, and there's our cruddy line of best fit. So go to y equals, and let's clear this out. So we cleared out that residual, or that old line of best fit. So go second quit, and we're going to say, all right, linear regression was garbage. Let's see exponential regression. So we're going to go stat, calc. We're going to go to exponential regression. All right. And now you could see what it looks like, but I actually want to store it so we can see the residual. So to store it, you're going to do this again. You're going to go second 1, so L1, comma, second 2, comma. So we're taking L1 and L2. And you got to put that other comma there. And now we're going to go vars, y vars, function y1. And there we go, meaning that we're going to store it in y1. So after we hit enter, boom, this is our exponential function. So it'll be y equals 16.8999, whatever, times 1.2 raised to the x power. And look at this. We stored it up here, and that's in your calculator. So if we go zoom 9, there's your scatter plot, and then here is your exponential line of best fit. Now that looks pretty darn good. Now one thing I didn't say is, if you look back at this problem, look at the line of best fit that the book gave you. So clearly this is like virtually identical. So clearly this must be correct, but that's not good enough, because what we have to do is we have to look at your residual data, your residual. So here's this is what I want us to do. So there's not a lot of work you can show. So what I want you to do is I want you to do 2 things. Number 1, I want you to draw me a scatter plot. So a scatter plot, just show me what you see on your calculator. So boom, look at that. Oh, my scatter plot looks amazing. Look at all those exponential. It looks exponential. So there's my scatter plot. All right. Then I want you to show me the line of best fit on there. All right. Not the blue one. The blue one is because I'm using my laptop and it sucks. All right. Then what I want you to do, is I actually want you to show me the residual plot. Now, residual plot really should have a y-axis and then an x-axis that looks like this. So we'll call this RP, our residual plot. So I want you to show me what the residual plot looks like. So, all right, once we've evaluated and we need to see our residual plot, we're going to go second y equals, and we're going to change our plot that we have on to our residual plot. So we go down to our y list, and we're going to change L2 to our residual. So we're going to go second stat, so to our list, and we go down to 7, our residual. Now, one thing to note, if you do not do your line of best fit, if you do not store it, and you do not see it, you will not see a residual plot. Your calculator basically does like a fail-safe. It won't let you do a residual because it hasn't seen anything. So you have to store your function in order to see a residual plot, all right? So anyway, L1 residual. So now after we want to see a residual, we go zoom 9. And that always fits your graph so you can see it perfectly. And look at that residual. That is a random residual if I've ever seen it. So you got a point, I believe this is a point here. So you got a point here, then you got a point up, down, 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 up, 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 down, up. So if you look, it's not U-shaped, it's random. So random equals good. So this is our line of best fit. This is your line of best fit because you get a random residual plot. So now it says use your results to predict the estimated wolf population after 10 years. Well, 10 years is your year since, so that's your x value. So what you're going to do is you're going to put 10 in for x as your exponent, and you're going to evaluate. Now, one of the cool things is because we stored this into, oops, sorry, we store it into our y1. You can calculate it using your calculator, or just go second graph, and that's your table, and just go down to 10. And that's another way to find exact values. So your population is about 120 wolves, and really you got to round up, so it's about 121 wolves in 10 years. All right, so I really don't want to do another one. I think after doing this and seeing this, I think you should be good. Why don't we do this? I want you to try number 3, and I'm going to show you what I have here. You should know how to plug it in. All right, I'm just going to quickly go over it, and then this is the best part, is what type of model is most appropriate. And we'll do this one, and then we'll be done, okay? Here we go. Pause the video, type this in, make sure you reset your calculator. All right, so here you go. Here's your data in your calculator. All right, so we're going to go second y equals. We're going to turn on our scatter plot. We'll go zoom 9, and boom. What does that look like? Now, if you think it's linear, we have an issue. If you think it's exponential, we also have an issue. If you think it's quadratic, you're good to go. So what we're going to do is we're going to go stat, we're going to go calc, and we're going to do a quadratic regression. That's one we haven't done yet, so we're going to go 5. Now you want to store this quadratic regression, so we're going to go, after you hit quadratic, don't hit enter again, go second 1, comma, second 2, comma, vars, y vars, function, y1. Now again, if you have the new school calculator, all right, you have to go and store it. Everything L1, L2 are good. You're storing, all you have to do is just go down to store reg EQ, and that's where you go vars, y vars, function, y1. So what you're going to do is you are going to now hit enter. There's your quadratic formula. We will store that in a second, all right? Well, it already is stored, but let's do this really quick, all right? So let's look at our graph. All right, there it is, and there is our line of best fit. So holy cow, I look at this sucker and I say, wow, this guy looked really good for our scatter plot, or SP, or scatter plot. So it looks like this, this, up here, up here, up here, down here, and then I'm going to draw my line of best fit. Wow, that looks so great. All right, and now to determine if this quadratic is truly the best one, I need a line of regression, or regression line. So you ready? Here's my line of regression. I have to see it. So I go second y, and I got to change my plot from a scatter plot to a residual plot. Now, since I did my line of best fit, all right, and it's quadratic, and I'm choosing quadratic, I'm going to go second stat, go down to residual, hit enter. So now I got L1 residual, and I go zoom 9 again, and holy cow, look at that. That's random. That is random. That's random if I've ever seen it. So above, above, below, above, 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 below. So this is random. So good. So random equals good. So that means this quadratic is the best model. So what we're going to do is we're going to write out our model that will produce the maximum profit. So we go y equals second quit, and here we go. So see, it's written in standard form. So we're going to y equals, now just give me 2 decimals, so negative 0.35x squared plus 20.63x, and then minus 104.14, and that is perfect with showing me your scatter plot, line of best fit in it, and then your line of regression, or your or sorry, not your line of regression, your residual plot. Sorry, it should be called RP, residual plot. I don't know, I was helping some other student out. Anyway, all right, your residual plot. So because we showed this, because we showed this, and we know it's random, therefore it's good, then this is our equation, and there's nothing else for us to do. So with that said and done, here's your homework. So you're going to work on page 143 through 145, 1 through 10. Please, you need to show, when doing these problems, you need to show your line of best fit, your scatter plot, and then your residual plot, all on every single problem if you're going to say it's a good line of best fit. Is that understood? And then answer the additional questions. All answers are in the back of the book. Make sure you're checking your answers. All right, and I will be here tomorrow. Thank you.